What's going on, guys? So today we're going to be talking about the mole. The mole, as the standard joke goes, it's not the animal you see underground. The mole is a concept that formulates the backbone of chemistry. It's really, really essential to understand this concept of the mole in order for you to pursue actual calculations later on. So what is the mole? Well, as a side note here, really quick, imagine I have 10 grains of sugar, okay? And I'll call that a foal of sugar. That's just an imaginary unit. But the foal means 10 of anything. That's basically what the mole is. So if I took, if a sugar molecule was, or a grain of sugar was something like 2 grams, that'd be like huge for a grain of sugar, but just in your mind, if a grain of sugar was 2 grams and I had a foal of sugar, I would have 20 grams of sugar. Okay? That's basically the same thing when we're talking about the mole. A lot of people will try to define the mole in terms of carbon or something like that. They try to formalize the mole to a point, but oftentimes it's essential for it. Sometimes understanding doesn't come formally to us, it comes a little bit more informally. And so the mole is no different. The mole is, you might think, is an arbitrary number, and it's 6.022 times 10 to the 23 of anything. Okay, that you might think that's a number pulled out of my hat. Well, it really isn't. It can be derived from thermodynamics. It can be derived from statistical mechanics and thermodynamics from physics. We're not going to do that, but we're going to say, for the sake of brevity and for the sake of chemistry, that the mole is 6.022 times 10 to the 23 of anything. It could be molecules, it can be atoms. And so I'll write this number down, and this number, 6.022 times 10 to the 23 is a huge number. If you think about it, this 10 to the 23 means tons and tons of trailing zeros after this 6.022. If you're unfamiliar with scientific notation, what we're basically doing here is we're taking this decimal, and if we want to get this whole number, we have to move this decimal over 23 units. So we just put a bunch of trailing zeros after this thing, and we move this decimal over 23 units, and we have a giant number. We have a number basically with close to 23 zeros trailing behind it. 20 zeros to be precise, because we're already moving 3 units over this way, so we need to move another 20 units to get a total of 23 movements of the decimal place over. So this is a really, really big number, and again, you might think this is an arbitrary number pulled out of my hat, but it really isn't, and it can be derived from physics. And this number is called Avogadro's number. I'll make that a little nicer. Avogadro's number. Avogadro was a famous chemist back in his day, and he came up with this number, derived it from Boltzmann statistics, and he said, this is a mole. This is what a mole of anything is. We could have a mole of carbon, for example, would be 6.022 times 10 to the 23 carbon atoms. Okay? Now let's come over here to the periodic table. So here I have the periodic table, and there's 3 things you want to observe in each cell of the periodic table. We have the atomic number, which is the number of protons, as we've discussed. The atomic symbol, which is the symbol that represents the atom of interest. And here I have just carbon as an example. And then we have this number right here. Okay, this number is called the atomic mass, or the molar mass. Okay, last time I believe we might have called it, we might have said it was in atomic mass units. Okay, but again, this is sort of the mass of a carbon atom, if you will, in a mole of carbon. Okay? So in a mole of carbon, we have 12.01 grams of carbon. So for 6.022 times 10 to the 23 carbon atoms, that makes up a total of 12.01 grams of carbon. Okay? And the way we can write this is we have 12.01 grams per mole. Okay? This is 12.01 grams of carbon for a mole of carbon atoms. Okay? This is a mole of carbon atoms, 6.022 times 10 to the 23 atoms of carbon. Now we can do this for nickel. Okay? All we'd have to do is say, okay, nickel, we'd have to figure out what the molar mass is for nickel. Okay? And then that tells us how many, that would tell us how much weight 1 mole of nickel is. Okay? That's really the basic understanding of the mole. So imagine now I have nitrogen dioxide, okay, NO2. Okay. So from memory, I've done this a lot. Nitrogen is about 14 grams per mole. So nitrogen is about 14 grams per mole. And then we have 2 oxygens, and from memory again, I have about 16 grams per mole for oxygen. This gives me a total of 14 plus 2 times 16 grams per mole for NO2. Okay? And if I were to actually do that, so we have 14 plus 32, so that's 14 plus 32 grams per mole. I'll just leave off units for now and then put the units back in later. So, and then that would become, that'd be 40, that's the same thing as 46 grams per mole. I'm doing all this math in my head, which I probably shouldn't be doing, but that is, so nitrogen dioxide is 46 grams per mole. Okay, that means if we have a mole, if we have 6.022 times 10 to the 23 atoms, or molecules of NO2, then we have 46 grams, roughly 46 grams of NO2. I approximated this 14 and the 16. There's some decimals in there. But that's the gist of Avogadro's number. That's the gist of the mole. We can now add molecules. We add molecules in this way to get what the molar mass is for a molecule. We can do this for huge molecules too. So if I had a mole of tetrodotoxin is a huge complex molecule that's associated with pufferfish poison. If I had a mole of that, it would be pretty heavy because tetrodotoxin is a very large, bulky molecule, so it would be very heavy. And if I had 6.022 times 10 to the 23 of those, I would have a very heavy amount of tetrodotoxin. I can almost guarantee that. Okay? That's the mole. That's the concept of the mole, and I hope this makes sense to you. And if you enjoy the way that I teach, please visit my website at tristancarmacy.com. If you're interested in private tutoring, online private tutoring, you can go there. Please hit that subscribe button if you also like this. Again, I'm going to be coming out with some physics this week probably, and I also am going to plan on starting another playlist on biophysics or bioengineering or physiology. Still trying to decide which one. But thank you for watching, and I'll see you in the next one.